Statistics Measures of Variability Formulae Part 21. In this part I have covered all the formulas related to measures of variability, means range, mean deviation, standard deviation and quartile deviation. So first formula, range. Range is equal to highest score minus lowest score. Very simple. In the given data, find out the highest score and the lowest score. Highest score minus lowest score gives you the range. So again this formula is very important for MCQ and competition point of view. Second formula, mean deviation from ungrouped data. MD is equal to summation mod x by n. Here MD means mean deviation, x means deviation of a score from mean, and two parallel x within two parallel line is pronounced as bar x or mod x or modulus x. Bars embracing the x indicate that signs are disregarded in arriving at the sum. Whenever we are summing the data, we will not take minus. Minus will be treated as plus sign. Means sum up. Modulus means magnitude. N is equal to number of score. Third formula, mean deviation from group data. MD is equal to summation mod fx by n. Here MD means mean deviation. Again x means deviation of score for midpoint from the mean. F means frequency. N means total number of frequencies. F multiplied by x means product of frequency and deviation. Summation, this sign is of summation, and fx between the two parallel line means mod fx or modulus fx. So modulus fx. Question formula 4, quartile deviation from ungrouped data. Q is equal to Q3 minus Q1 divided by 2. Here Q1 is equal to 25th percentile, Q3 is equal to 75th percentile, Q is equal to quartile deviation. Here Q1, how the Q1 is to be calculated? Q1 is equal to n plus 1 divided by 4th score, and Q3 is equal to 3 within bracket n plus 1 divided by 4th score. N is the number of score. So putting the values of n here, we will having Q1 and Q3 and substituting the value of Q3 and Q1 in this equation, we have the quartile deviation Q. Now next formula, question formula number 5, quartile deviation from group data. Again the main formula is as it is same, Q is equal to Q3 minus Q1 by 2, but Q1 is calculated by the different way. Q1 is equal to L plus n by 4 minus F divided by FQ multiplied by CI. Here Q1 is equal to Q is equal to quartile deviation. Q1 means it is that percentile below which 25th frequencies n by 4 are lying. Q3, it is that percentile below which 75th percent frequencies 3n by 4 are lying. L is equal to exact lower limit of the class interval in which first quartile Q1 or third quartile Q3 lies. N is equal to total number of frequencies. F is equal to cumulative frequencies up to the class interval which contains the first quartile Q1 or third quartile Q3. And FQ is equal to frequency of the class interval containing the third quartile Q3 or first quartile Q1. I or CI means class interval or length of class interval. Here one more equation, as Q1 is to be calculated, similarly I am writing here Q3. How the Q3 is to be calculated? Q3 is equal to L plus 3n by 4 minus capital F within one bracket whole divided by FQ and multiplied by CI. 3n by 4 means 75th percentile. 3n by 4. So from this equation we will calculate q1, and from this equation we will solve q3 values, and putting the values of q3 and q1 in this equation we will be having quartile deviation from the group data. So this is all about quartile deviation from group data. Now formula 6, standard deviation from ungrouped data. SD, or this is small sigma, is equal to under root summation x square by n. Here SD or sigma is called standard deviation. Small x is equal to deviation from mean. Capital X is equal to score. Capital M is equal to mean. Small x is equal to capital X minus m. X square is equal to square of deviation, and this sigma is equal to summation n is equal to number of scores, and this sign is called square root or under root. Now formula 7, standard deviation from ungrouped data when the assumed mean is taken as 0. So SD is equal to under root summation x dash square by n minus m square. This notation is also called x prime. So here SD is called standard deviation and x prime is called deviation from the assumed mean. This letter is called x prime or x dash. X dash square is equal to square of deviation from the assumed mean. Summation x dash square means sum of the squared deviation taken from assumed mean when the assumed mean is 0. M is equal to mean. M square is called square of the mean, and n is equal to number of scores. Formula 8, standard deviation SD from group data by long method. So the formula is SD is equal to under root summation fx square by n. Here the symbols have meaning as it is as usual. SD is called standard deviation. This is called sigma and pronounced as sigma and used for summation. F means frequencies. X is equal to deviation from mean. X square is equal to square of deviation from the mean. F multiplied by x square is called square of deviation multiplied by their respective frequencies. N is equal to number of scores, and sign this is called square root or under root. So this is all about formula 8, that is standard deviation from group data by long method. Now standard deviation from group data by short method, there are three formula for this calculation. SD is equal to I within square root summation fx square by n minus c square, equation number 1. One way to calculate SD from equation number 1. Second one is I under root summation fd square by n minus within bracket summation fd by n whole square. This is equation 2. So in this way we are having two equation, and later on we will take up one more equation. So standard deviation from group data by short method is calculated by three equations. Here symbols have meaning as it is. SD is equal to standard deviation, F is called frequencies, X is equal to deviation, X square is known as square of deviation. F dot X square is equal to product of frequency and square of deviation. Summation fx square is equal to sum of the product of frequency and square of deviation, that is also known as sum of frequency multiplied by deviation square. Fx is equal to product of frequency and deviation. Summation fx is equal to sum of the product of frequency and deviation, that is sum of frequency multiplied by deviation. N is equal to number of scores. I is equal to class interval is equal to length of class interval, also known as length of class interval. C is called correction. Here C is called correction. In equation 1, here this C is known as correction. And this sign is called again square root or under root. Now formula for correction is separately given here. C is equal to summation fx over n, or C is equal to summation fd by n. Therefore C square is equal to summation fx by n whole square, or C square is equal to summation fd by n whole square. So in some books correction is given by summation fx by n, or in some books summation fd by n. Now Formula 10, standard deviation SD from group data by short method may be calculated by one more equation given below. SD is equal to I by n within bracket, within square root n within bracket summation FD square, this is FD square, and minus summation FD whole square. So this equation 3 is equivalent to equation 2. In part 18 I have proved this, that these two equations are same, equation 2 and 3. Now formula 11, combined standard deviation. Combined standard deviation SD combined, represented by SD combined, is equal to under root n1 within bracket sigma 1 square plus d1 square plus n2 within bracket sigma 2 square plus d2 square divided by n1 plus n2. Here sigma 1 is called standard deviation of the first distribution, sigma 2 is called standard deviation of the second distribution, d1 is equal to m1 minus m combined, d2 is equal to m2 minus m combined. n1 and n2 are number of two distributions, total number of two distributions separately. One distribution 1 has n1 number and distribution 2 has n2 numbers. m1 and m2 are known as mean for two distribution, and m combined is called combined mean. So combined mean is to be calculated by this equation. M combined is equal to n1 m1 plus n2 m2 upon n1 plus n2. So in this way, first we will calculate m combined, and then value of m combined is to be put here in this equation. Then we will find d1 and d2 using d1 sigma 1 sigma 2 d1 d2 and n1 n2. In this equation we will be having combined standard deviation. So this is all about measures of variability, and from this chapter I have covered all the formula. 11 formula I have covered in part 21. So this is all about this part. Please subscribe the channel, press the bell icon, and please share the video. Thank you, and please subscribe the channel. Don't forget to subscribe. Please subscribe the channel. Thank you.